When we first talked about multiplication, one of the first things we described, and really we would do this with students too, typically when we first describe multiplication, we describe it with the repeated addition or repeated sums or groups of objects model, right? The idea that when we are multiplying numbers, all we're really doing is repeated addition. So for example, 4 times 6 is really the same thing as adding 6 4 times. And that's our most basic, most common definition of multiplication. So that's typically where we would start when we first describe multiplication to students. We would do this similarly when we first describe division, right? So if multiplication is repeated addition, then division is just repeated subtraction, right? So similarly, for an operation to be division, we have to be subtracting the same number over and over. And so how we do that can vary. So if we look at a couple examples here, this first one says a teacher has 60 markers and 22 students in his class. If he gives the students the same number of markers, how many markers will each student get? And if there are any markers left over, how many are there? So we can think of this as like our sharing or partitioning problem. So we're talking about, I have 60 markers to give out. I don't know yet how many each student is going to get, but you can imagine if I were actually doing this and I had 60 markers in front of me and 22 students in front of me, in theory, I could, let me just give one marker to every student. And so then every student has a marker, and then I'll see, do I have enough to do that again? Let me give another marker to every student, and see what's left over, and then look and see, do I have enough to do that again and give every student another marker? And so like in theory, we could do it that way, right? So how can you actually compute that though? So, rather than actually drawing a picture every single time I want to do this, or actually handing out markers every time I want to do this, we could just say, okay, what's the process going on? I'm starting with 60 markers, right? If I start by giving every student in class one marker, that means I just handed out 22 markers. So really that's the subtraction. Let me see what's left, right? So if I take 60 minus 22 with whatever subtraction algorithm you like, we should see that we would have then 38 markers left over. And so from that, do I have enough to give all of my students another marker? Yes, I do, because 22 will go into that. So let me give every student another marker. So now I just gave out another 22 markers. Let's see what's left. So subtract 38 minus 22. I get 16. And then there I would look again and say, okay, do I have enough markers in my box that I could give everybody another marker? And say, no, I'm only counting 16. That's not enough to give everybody another one. So that's where I'm going to stop, right? So here I will stop because I can't subtract 22 anymore. So how would I figure out what the answer is here? I would look and see, well, how many times did I give markers to my whole class, right? How many times did I subtract 22? And so I can see, okay, I gave everybody in class markers one time here, right? So that was 22 markers. And then I did it again. So here's the second time, or the second marker. And then I had to stop there, right? So I can see here that the quotient in this problem is the number of times that we can subtract 22, which in this case is 2. So in this case, we can say the answer is 2 markers each. And that's our quotient, and then there is a remainder. So we have a remainder of 16. 16 what? In this case, 16 markers. So let's do this for another example. This one is not a story problem, it's just compute 85 divided by 14 with repeated subtraction. So you could think of it the same way though. Imagine you had 85 markers and 14 students in your class, right? So I'm just going to continually subtract 14, right? So 84 minus 14 should give me, I'm sorry, I started with 84, that should be 85. That's better. So 85 minus 14 should be 71. Do I have enough to subtract another 14? I do. So let me do that again. So let's see, 71 minus 14. Let's do 11 minus 14, which is 7. And then I had to exchange, so that's going to be a 5. I've got enough to subtract another 14. It's going to be 3 and 4, so 43. Just because I'm running out of room, I would typically just keep going vertically, but I'm going to go over here where I have some more room. I have enough to subtract another 14. So let's see, this would be 13 minus 14 is 9, and then that would be 2. I have enough to subtract another 14. Leaves me with 15. Do I have enough to subtract another 14? Yep, just one more. And that leaves me with 1. So you can imagine if I were talking about 85 markers and I'm dividing that among 14 students, I gave each student 1 marker, each student got a second marker, each student got a third, a fourth, a fifth, and a sixth. So I was able to give markers out 6 times or give 6 markers out, right? If this were a story problem. In this case, though, we'll just say my quotient was 6, and then because that's how many times I subtracted 14, and then I had a remainder of 1. So you can see here, this is a method for how you can find the answer to a division problem. Sometimes it's not too bad. Like example 3, I only had to subtract 22 twice, right? So honestly, if a student goes through it this way, they understand what division means. That means we're going to subtract over and over. So it's a good method. You can see though, it does get tedious, right? So like 85 divided by 14, I had to do that several times. So it gets a little bit long. And imagine instead of 85 divided by 14, what if that were 185 divided by 14 or 1085 divided by 14? This would take quite a bit longer using repeated subtraction, but it is an efficient method that will get you your answers, just maybe more long or tedious depending on your numbers.